Okay, let's talk about functions. And this happens to be a function right here. And in particular, this is something we call a mapping, okay, a function mapping. And you have to understand this. So if you're taking any sort of algebra course, you need to know a lot about functions, okay? Functions, if you just think about the description of things that you learn, like linear functions, quadratic functions, polynomial functions, this word is thrown around. And you have to understand specifically what that word means, functions. There's a lot to know about functions, how to find the domain, range, whether something's a function or not. But just remember, okay, that functions are fun. Now, some of you are going to be saying, oh, okay, Mr. YouTube Math Man, don't try to be funny. Just teach me the math. Stick to the math. Listen, I got to try. Let's lighten it up and let's learn a little bit about functions and mapping in this particular video. Now, I got a question for you. What if I said, this isn't a function, or if I just asked you, rather, okay, is this a function? Okay, I'm asking you, is this a function? Does this mapping represent a function? Could you tell me why? Okay, could you say, yes, it is because of what? Okay, what would you put? I'm just curious, all right? Put your answer in the comments section. And if it is a function, what is the domain and range of this function? Okay, could you answer this? Pretty easy to answer if you know what you're doing. But I'm going to get into specifically how to interpret a function mapping. Very, very important that you understand this. Now, before we get going, let me just show you very briefly. We oftentimes see functions written this way in algebra, like f of x is equal to 3x squared plus 1. So if you're saying, oh, functions, isn't this a function? Yeah, that's a function as well. Also, like graphically, we can express functions. We can also express functions in terms of sets of numbers. Let me just write something out, like 1, 3, -2, 5, things like this. There's various ways we can express functions to include a mapping diagram. Okay, so that's what we're talking about here. So if you've seen these type of problems in your class or quizzes, tests, and you're not quite sure how to deal with them, well, I'm going to show you exactly, precisely how to answer these basic questions. One, is this, does this mapping represent a function? And if so, can you tell me the domain, range, and maybe even whether this thing has an inverse and what the inverse function is based off this mapping diagram. So we're going to get into all of this in just 1 second. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. I'm going to leave a link to my math help program in the description of this video. But basically, I have 100 plus different math courses ranging from pre-algebra to pre-calculus and everything in between. So if you're in middle school, high school, or even college, I can help you pass your math course if you're taking any exam that has math on it. So for example, the GED, SAT, ACT, GRE, GMAT, ASVAB, Accuplacer, ALEX, teacher certification exam, nursing school entrance exam, you get the idea. I could help you prepare and pass those exams. Of course, you just go to my website and check out my full course catalog to get your specific test prep course. If you homeschool, I have a very comprehensive homeschool math curriculum, and if you don't have any math notes, you can use mine. I'm gonna leave links to my math notes also in the description of this video, but hopefully you don't need my notes because you should be taking great math notes, okay? I've been teaching math for decades. Those students who take excellent notes almost always end up doing fantastic in mathematics. All right, so again, if you know why this is a function, tell me why in the comment section, and then tell me what the domain and range is. I'm saying it is a function, but we're going to get into this now, okay? So let's talk about functions and what's this whole thing about? Well, in mathematics, in algebra, okay, or this whole concepts of functions, let's just break it down like this. There is something called relations, okay, in math. And you can think of relations as simple XY points, just points on the XY plot. Okay, so here's an X and here's a Y. It's a terrible XY plot, but you get the idea. Here's the little points. So relations are just collection of points. That's one way we kind of think of relations. So points, 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 and each one of these points have a coordinate, right? Like this would be like, say, 3, 5. This might be 2, -7, whatever the case might be. That's effectively what relations are. Now, some relations are functions. Okay, this is the thing that you need to know. Some relations are functions. So all functions are relations. Some relations are functions. Okay, so if I'm asking you, whether this is a function. If you say no, well, then it's represents a relation in mathematics. So this is hopefully, review for you. But if you didn't know that, now you do. So how can I determine this? Well, a function, basically, there's various ways you can kind of think about it, but here is effectively what's going on, okay? Our x values, we have x and y, and this x and y represent the x and y points like on the xy plane, okay, like a point that we can actually plot. So here's x and here's y, and you notice that x is mapping to y. Okay, so here is this 1 maps to 2, represents the point 1, 2. This 3 maps to 9, represents the point 3, 9, and of course 7 maps to 0, represents the point 7, 0 on the xy plane. Okay, that's what that's how you interpret a mapping. But more importantly, to determine whether this mapping represents a function, here is how it works. Okay, for every x, okay, this x can map to only one y, one and only one y. Okay, so here, 1 maps to 2 and only 2. Okay, it's from x to y, right? 3 is going to 9 and only 9. Now, what if I put in this? All right, here was our question. So does this represent a function? All right, so you would look here like, okay, 1 is going to 2 and only 2. 3 is going to 2 and 3 is also going to 9. So no, this is not a function. Okay, this would not represent a function. This would be a relation. Okay, so this would be a relation, and that would be that. Okay, so that's how you would answer that type of question. But let's take a look at another situation. What if we had the following, okay? What if I took this away and I said is this a function? Okay, is this a function? So you would say, okay, 1 is going to 2 and only 2. 3 is going to 2 as well. Now, some of you are going to say, no, this is not a function. This is a relation. No, this is also a function. This is okay. Now, this x is going to 1 and only 1 y. It could be the same y as another x. That's okay. Okay, as long as this 3 is not going to anything else, it's not trying to go to 2 different or 3 different values, this is okay. All right, so this is a function as well. 7 maps to 0. So just to take that confusion out, this is a question that you're going to see when it comes to mapping. You got to be able to interpret this, okay? All right, so if you understand that, then this is excellent. So our x here, our x values here represent the input, okay? And the y values represent the output of this particular function. So we know that this mapping does represent a function, and the set of all input values, this is what this little circle or the little ellipse represents. This is the set of all input values happens to be the domain, okay? So the domain of this function is 1, 3, and 7. So if you got that right and you put that into the comment section correctly, then I must give you a little happy face with an A+. Very, very good, okay? So this is the domain of this function, 1, 3, and 7. All right, now there's various ways I can represent that. I just want you to identify that these values here are in fact the domain of this function, okay, this particular mapping. All right, what's the output value? Well, the output value, we call that the range, okay? So what's the range of this function? 2, 9, and 0. If you got that right as well, then I must give you a few extra little stars here to make you feel extra special. So that's excellent, okay? So let's just kind of quickly review what we've learned. All right, one, we, first learn how to look at a mapping diagram to determine whether it represents a function or not. Okay, that's number one. I just showed you how to do that. Remember, every x can only point to 1 and only 1 y. As long as it does that, various x's can point to the same y. That's okay, as long as an x is not trying to split off to multiple different y's. That fails. Okay, that is not a function. So that's the first thing. Now, once we know we actually have a function, this right here, the set of input values are our x values. Okay, we also call this our independent variable, and then y would be the dependent variable. But let's just kind of keep it simple. these x's right here, the set of these numbers is our input value or our domain, and then we have a respective or dependent values, they're dependent upon our input values. This is the range, okay? All right, so domain and range, so that's excellent. So now let's talk about function inverse, right? So if I said, tell me what the inverse function, construct a mapping diagram for this inverse function. So what would that look like? Well, this is really cool stuff. Let me go ahead. I'm sorry, I'm going to have to erase your little happy face right here. Let's just kind of clear this up here. All right, so when we have a function, and if this function, now here's an interesting thing. If you have a function, okay, some functions have function inverses. Not every single function has an inverse. So that's the first thing, okay? And then there's additional tests that you can run on this. But what we can do, if this thing does have a function inverse, here's the domain and here is the range. Here's how this would work, okay? The range becomes the domain, and the domain becomes the range. So let's go ahead and construct that now. And I'll go ahead and put two little ellipses here. And let's first get our range. That was 2, 9, and 0. Okay, 2, 9, and 0. And our domain was 1, 3, and 7. 1, 3, and 7. So now the range, which was the range in our function for the inverse function, this is going to become the domain, and the domain of the original function is going to become the range of the inverse function. So our mapping would look like this, okay? And now let's take a look at it. 2 is going only to 1, yes. 9 is going to only 3, and 0 is going to only 7. So I could get really fancy with you. I could say, okay, given this mapping, 1, determine whether this is a function. Okay, so if you're in my math class, I might give you like a little pop quiz like this. And 2, determine the domain of its inverse, if it has an inverse. So now some of you would be out there, be like, hey, wait a minute, hold on here. That's like kind of crazy. What are you talking about? I could tell you the domain. No. Tell me the domain of the inverse function. So you would have to go, all right, I'm going to have to write it this way. I know the range is not going to be the domain, and the domain is not going to be the range. Okay, so now the domain of this inverse would be this, okay, which would in fact was the range of the actual function in and of itself. So again, functions, mapping diagrams, very, very common way to represent functions. You need to understand them because teachers love to give these mapping diagram questions. It's important you understand this stuff. It's not just that teachers are trying to, catch you off guard, whatnot, but again, this whole idea of functions is everywhere in algebra. You got to understand mapping diagrams. You got to understand function notation, how to graph functions, how to represent functions using various sets, things like the vertical line test, horizontal line test, how to actually compute and find, or not compute, but actually find the inverse function of a function. All this kind of stuff I can help you out with in my additional videos on my I believe most of this stuff will probably be in my algebra playlist in my YouTube channel. But if this little video right here helped you out, please consider smashing that like button. That definitely helps me out. And if you're new to my YouTube channel, hopefully you'll consider subscribing. I've been on YouTube for 10 plus years, have over 1,000 plus math videos, basic to advanced math, have a tremendous amount of content. My goal always is to try to teach math in a clear and understandable way. Everyone can learn this stuff, okay? Mathematics. If you've been having a tough time, well, first, make sure you're fully focused, okay? The best way to do that is to be highly engaged, taking great math notes, and then, talk to your teacher. Look for someone, hopefully your teacher teaches in a way that you like and understand, but if, you don't really connect with your teacher's teaching style, find someone that you do like to learn from, okay? And if that happens to me, well, that's awesome. Please take advantage of the videos that I've made and I will make, but my best math help will always be within my math help program. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.